Students, in this problem, we're going to find the pressure that is 120 meters below the surface of the sea. We know that the density of the seawater is 1.026 grams per cubic centimeter. So let me explain something. If we are going to find the pressure on this point A, that is H units, that means meter, feet, or whatever, under the sea level, you know that the pressure here at point A, due to the column of liquid, the column of fluid, the of liquid that you have above the point A, will be the density times the gravity times the height. Nevertheless, we have here, if the vessel is open, or if it's the sea or a river, or any other place with water, a lake, you have a pressure of 1 atmosphere. That is the common pressure, that we have when we are at the air, right? So if we want to find the total pressure here, we're going to say that the total pressure would be the pressure of the atmosphere, right? So I will call the pressure here at point A, that is 120 meters below, P2, equal to P1, that I'm going to say that is the pressure, of the atmosphere plus the pressure due to the column of liquid. There is density times gravity times H, right? So in this case, when you do this, you find the total pressure, right? If you don't add P1, that means if you say just P2 equals rho GH, what you find is the pressure due to the column of liquid. So I'm going to say in this problem that P2 is equal to, I know that 1 atmosphere is equal to 1,325 pascals. 101,000, sorry, 101,325 pascal. 101,325 pascal. This is 1 atmosphere. And we know that H, how deep is just this point, is 120 meters. And we know that if the density of the sea water is 1.026 grams per cubic centimeters, this would be the same that, 1,026 kilograms per cubic meter. So if I substitute, have 101,325 pascal plus the density, that is 1,026 kilograms per cubic meter times the gravity. I'm gonna take to make it easier. No, well, I just solved it with 9.81. So 9.81 meters per square seconds, times the height, that is 120 meters. Okay, so now we have, you can cancel this meter with one of the meters here below, so we get meter square. So we have kilogram meter square second, that is newtons, over meter square here, that will be pascal, right? So we multiply this 1,026 kilograms per cubic meter times 9.81 meters per square second times the 120 meters. The output unit here is pascal, right? So I'm going to say that the pressure now of that point, that is 120 meters under the water, will be the 1,325 pascal, that is the atmospheric pressure, plus, and in this case, then I'm going to say that the value will be 1,309,132 pascal. So it would be Sorry, let me double check here my calculation include already, the 101. So let me do something. Let me erase this here and let me calculate this again. So I'm gonna say I'm going to say 1026 times 9.81, just to make sure that I have the correct number. 9.81 times 120. This will be 1,207,807. So if we add, so let me just type this value here, is 1,207,000. What else? 807 Pascal. And if we add, these two values now, is when we get plus 101,325. This would be the 1,309,000 132 Pascal. Now, so we have here 1.309 megapascal. You want to convert this into megapascal. Mega is 10 to the negative 6. Sorry, it's 10 to the 6 Pascal. So you can say that this is 1.31 megapascal if you want to convert this into megapascal. Or you can say you want to express this value in kilopascal, 1,309 kilopascal approximately. Or if you want to convert into atmospheres, this value over here that we have in pascals would be equivalent to 12.92 atmospheres. So we found, the pressure that we had in the point there is 120 meters under the water. The pressure that we have calculated was the total pressure, that includes, of course, the pressure due to the atmosphere.